So I'm going to show you how to make an origami pentagon, but this is for what's called a Cairo Pentagonal or Pentagonal tiling. And it's named after tiling that shows up in streets in Cairo, Egypt. And I've seen directions for making this Cairo Pentagon tile. It's not a regular pentagon, but the instructions I found come up with this one here. And this has a sort of vertex angle of 135, these left and right angles of 90, and these base angles of 112.5. But the actual pentagon that the Cairo Pentagon tiling is based on has a vertex angle of 120, side angles of 90, and base angles also of 120. And by having this configuration, you get this really satisfying pentagonal tiling of a Euclidean plane. So after some playing, I think I've found out a way to take a square piece of paper and come up with this origami pentagon here. All right, so start with your square piece of paper, and your first step is to fold it in half vertically. That's going to give you the midline of your square. Now from here, what we're going to do is we're going to do some folds that will yield an equilateral triangle, and I learned this from Paula Krieg. So what I'm going to do is take this bottom left-hand corner and bring it up onto that midline fold, but make sure that the edge of the paper forms a nice point with the bottom right-hand corner of the square. It looks pretty good. Okay. Now you're going to take the right edge of the paper and you're going to fold this down over. And again, you want these edges to match up nicely. Okay, give it a good crease. And you can open that up. Now we're going to repeat that on the opposite side. So now I'm going to bring this bottom right-hand corner up. And this corner is going to match. Let me grab my pencil here. There's a point of intersection with these two folds. So I can just sort of cheat by lining up that corner with that point. And then there's a crease here. And I'm just going to match that up with this crease here. All right, so I can use those creases as kind of guidelines to help me. All right, and then we're going to bring this fold over here. I'm just going to turn my paper a little bit to work things through here. All right, so now we can open that back up. All right, so now you can see the equilateral triangle that's formed here and here. All right, so that's a nice equilateral triangle, and you can cut that out if you want to do that. But we're going to continue on with the pentagon. You can actually see a 5-point star beginning to take shape here. Okay. All right, now we're going to take the, it doesn't matter, top right or top left, because I'm going to do both. I'll start with the top right here. I'm going to bring that down onto this crease right here. Again, trying to get it to line up nicely. And then you can open that up. And then you notice that that crease goes right through that point of intersection of the other folds. And same thing on this side. Bring this sort of 90-degree angle down onto this crease right here. And again, that crease goes right through that same point. Okay. All right, so now we're going to fold those back down. So I'm going to bring this right hand flap back down and this one down on top of it. And as I do that, these are going to kind of come together, get this nice little triangle shape right in here. Okay. All right, so that right there is the 120-degree angle at the top of the tile. Okay. All right, so now what we're going to do is we're going to bring this bottom left-hand corner up so that the left edge that remains of the square matches this edge right here. And then we'll do the same thing on the other side. And then you notice that those two flaps meet right here. That's actually at the intersection point of what would have been the medians of the equilateral triangle. Okay, so now that gives us the 120 at the top, and it gives us the 90 in the corners. All right. Now, there's a very specific size length for the bottom side. These four sides here are congruent, or they're going to be congruent. They're not yet, but they will be, all right, with that Cairo Pentagon. This side here has a ratio. If this is 1 unit, this one here has a ratio of rad 3 minus 1. All right. So to get that, what you're going to do is you're going to bring this edge to line up with this edge. You want to make sure that they line up. And you'll notice that this is longer, right? If I kind of fold this back, you know that it overlaps, and that's fine. And what we're going to do to make sure, because again, what we want is we want these four edges to be the same length. So to achieve that, what we're going to do is we're just going to take this, I'm going to flip it over, and you'll see there's like a little trapezoid peeking out there. We're going to fold that over. All right, so now when I pull that off, this side and this side are the same length. And that's it. Flip it over. So if this side is 1 unit, this side is rad 3 minus 1. And then you've got a 120-degree angle at the top and down here at the bases. And these are 90-degree angles here at the left and right. Again, not a regular pentagon. But the nice thing is if you get a bunch of them made, I made a whole bunch yesterday, is that these form a really beautiful tiling. All right, so you can put those two together, and then this one goes here. This becomes sort of the base unit of that Cairo tiling. And then you can tile a plane in that continued fashion. So I hope this has been helpful and useful and interesting to you. I encourage you to go ahead and do some research into the Cairo tiling and have some fun playing with math.